For question 3, answer the following using the Bronsted-Lowry definition of acids and bases. Write the chemical equation for the acid-base reaction between acetic acid and water. Here is my chemical equation. In your chemical equation, label all the reactants and products using the following items: acid, base, conjugate acid, conjugate base. So my reactants, I've got my acid and my base, and my products, I've got my conjugate base and my conjugate acid. For letter C, write the equilibrium constant expression for this reaction. So here's my equation. It was just the products over the reactant, discluding water as part of my reactants just because it is a pure solution and that K value is always going to be constant. If acetic acid is a weak acid, is the value for K greater than 1, less than 1, or equal to 1? Explain how you know using the definition of a weak acid. So, the K is going to be less than 1 because a weak acid only partially dissociates in water. So only a fraction of its molecules donate protons to water to the H3O positive in the acetate. In the human body, pH varies drastically among different organs. How would a molecule of acetic acid behave differently in the stomach, which is a pH of roughly 2, compared to the small intestine with a pH of roughly 8? In other words, which form of acetic acid, or the acid or the conjugate base, would predominate in each organ? So, the pH of the stomach is much lower than the pKa of the acid. So in the stomach, the acid would predominate. The pH of the small intestine is much higher than the pKa of the acid. So in the small intestine, the conjugate base predominates.